Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics, and today we will start with lecture 3 and again we will continue with the introduction to Engineering Econometrics. Let me highlight the lecture contents and the coverage of this lecture will be like this. So, we will start with requirements of engineering econometrics, components of engineering econometrics, understanding variables, understanding of data, then data architecture, then data analysis process, and finally, we will discuss something related to data analysis softwares. As we have already discussed, engineering econometrics is a kind of quantitative subject, and it includes the kind of problem, that is the theory. Then it will be connected with the data, mathematical application and statistical application, and then we will empirically verify to this theory and looking for some kind of new insights. So, in total it is the integration of theory, data, mathematical tools and statistical tools, and the most important component is the data, through which we can connect theory with model, and then in the process of that is the empirical process, we will get some kind of new insights, and that will address the particular engineering problems in a kind of much better way. So, that is how we are here to know certain requirements. So, what are the specific requirements before we go for the kind of engineering econometrics. Technically, engineering econometrics is a kind of tool baskets. So, here we will first pick up the particular engineering problem, and then we like to pick up certain techniques and then connect with the data, and then empirically process is to get some kind of econometric estimated output, and that output can be helpful to analyze the problem in a kind of better shape. So, the particular requirements are like this. So, we have to understand very carefully the variables, that is the decision variables. So, in the econometrics kind of a requirement, that is the engineering econometrics requirement. So, one of the most important is the data, and data will be very meaningful when we connect with a kind of concept called as variables, that is the decision variables. And we have already discussed that the entire subject is more or less connected with the regression modeling. So, when we talk about the regression modeling, the simple structure is the establishment of relationship among the decision variables. So, we will discuss details about the regression modeling after this lecture, but before we start the process of regression modeling. So, we must know certain requirements, until unless you clear about these requirements and the kind of concepts. So, you are not in a position to do some kind of empirical testings or the use of engineering econometrics to the particular engineering problem. So, the first and requirement, the need of understanding is the variables. So, since it is a kind of regression modeling application, so the variables can be two types. So, the dependent variables and independent variable, and in the regression modeling, so at least two variables must be there in the system, and out of which one must be dependent variable, another must be independent variables. So, from engineering to engineering, the concept of dependent variable, independent variable varies from one point to another point, which I will address in a much better way in the next slide. But in the meantime, in the simple language, variables means it is a kind of instrumental in understanding problems relating to engineering econometrics. So, that means through variables. So, the theory can be quantified, and first we quantify in a kind of mathematical form, and then we transfer into a statistical form, and after that we can connect with data and looking for estimation process, that is the empirically investigation process, and then we look for the kind of new insights on the basis of empirically estimated derived output. And the second requirement is the data. So, that means the first requirement is the variables and the second requirement is the data. So, now data itself cannot be meaningful until unless you point out the variable structure. So, any information behind this variable is called as data. So, that can be represented in various ways. So, data can be for a organization for that particular variables, and that too with respect to different point of time. So, there are many ways you can actually understand the concept of data. In fact, we have separate slides to detail about the data structuring, data architecture, etc. But in the simple language, data means collected facts and figures for the decision variables. So, the decision variables reporting may be for a particular organization, for a particular department, and for a particular department with a different point of time, for a particular organization with a different point of time. Like that, there are many different ways you can actually specify the kind of data as per the engineering econometrics requirement. Then next concept is the database. So, that means any information related to variable is nothing but called as data. So, now for engineering econometrics, and that too when we solve some kind of engineering problems, you need actually data for these decision variables, and so it is not so easy to have data and just collect and start working on. It is not altogether easy process. So, there are two ways you can have the data for the kind of engineering econometrics requirement. So, it is a primary source, that is called as a primary data, and the secondary source it is called as secondary data. Primary source means you go to the particular respondent or a particular organization at a particular point of time, and then have the information corresponding to that particular decision variable. If that is the case, that particular collection process or the reporting process is called the primary data. And sometimes when somebody collect the data from the first end, that is called as a primary data, and when it will be recorded somewhere else, then it is called as secondary data. That means, if the same data will be used by second person, then it will be treated as secondary data. So, that is how the database structure is there. So, database you will find plenty of database where a particular organization will keep the data in storage because of their requirement or because of their business or something like that, and a researcher or the kind of investigators, his or her job is to have this data from the database as per the engineering econometrics requirement, and then go for the kind of empirical process or the kind of empirical testing. So, so understanding variables, data and databases are mandatory requirement for engineering econometrics, because knowing the database it will be very cost effective. Otherwise, if every time you have to go to the respondents or the particular organization and collect the data or report the data. So, now if some data same data is available somewhere else, which you may have knowledge, very sufficient knowledge, then it is better to go there and you can have the data for your requirement. And of course, some database is free and some database is a paid kind of concept. So, whatever may be the issue, so whether it is a free service or paid service, but it is a kind of basket where data is readily available. You just go and have it as per your requirement, and then go for the kind of empirical testing. And next item which we need for engineering econometrics is the econometric softwares. So, now we are in a kind of concept called as analytics environment or analytics world, where we have a plenty of data. That is what we call as big data. So, that means there is a huge pool of data. Of course, it depends upon problem to problem or variables to variable. So, assuming that for a particular problem, for a particular variables, we have big data points. That means that is what technically called as a sample size. So, usually in a kind of econometrics process, larger the sample size, that means larger the data availability, better is the model accuracy or better is the estimation process. That is not 100% correct, but somehow it is a significantly or considerably true that increasing the sample size or increasing the data points, your model accuracy or model fitness will be much better. And when you have a plenty of data, so that means a large sample size, and there are a large number of variables involved in the process. In fact, I will tell you the structure of regression modeling, where we can have a simple regression modeling, multiple regression modeling, multivariate regression modeling. So, when we start from simple to multiple, multiple to multivariate, then the degree of complexity will start increasing. So, when the degree of complexity will start increasing, and that is one way, and again the degree of complexity will increase with respect to increase of sample size. So, in whatever case, when the complexity is very high, so manually to solve the problem, that means testing in the model empirically is not so easy. So, in that context we look for some softwares which can easily process the kind of the engineering requirement, and then come with a kind of estimated output which can give you better results as per your requirement. So, that means the same thing which you are doing earlier manually. So, now you will do through mechanical process, that through softwares. In fact, softwares are it is a kind of business now. You will find plenty of econometric softwares which you can actually use to have the empirical output, and this empirical output will be very useful for your engineering problems requirement. So, we have a typical slides to tell you the number of softwares which are available in the market. You can use any one to use in your engineering econometrics, and sometimes when your problem is very big and very complex. So, that times the use of econometric software is a kind of mandatory, and typically when the problem is actually research oriented, then in that context. So, it is not so easy to handle the issue manually, that is the first issue. And second issue, it can give you a quick service or quick output. So, it means the thing which you can do manually 2 hours. So, within 2 minutes you can get the results. So, that is how a software is very easy to handle the process or manage the situation. So, so what is the suggestion here is that you must be acquainted with econometric softwares if you are working on engineering econometrics. And last but not the least is the structure called as informations, that comes from analyzing the data. So, that means we start with some information, that is called as data, first hand information, and data is a kind of input in the econometric process. Then in the econometric process you will also get some kind of quantitative information, that is called as econometric output. So, that is usually we like to say that analyzing the data. So, now in the first hand input, that is the structure called as data. Again the second hand information, that is again called as econometric output. So, we will see what is the information behind this empirical results, and how best we can use as per your engineering requirement. So, like this, so what we can say that there are huge number of requirements in the case of engineering econometrics. So, that is why we like to understand all these things. Let us start the little bit understanding about the econometrics process. So, what are the actually components under engineering econometrics? Of course, I have highlighted the details in the previous slide. What is happening here. So, we have a two different umbrella. So, in one umbrella we have econometric inputs, and another umbrella we have econometric outputs. Of course, the econometric output is derived from the econometrics input umbrella. So, in the input baskets, you have engineering theory, then mathematical models and statistical theory or statistical model, and variables, details variables are there, and then you must have a data, and then you must have a softwares how to apply the data as per your requirement, and then you must have computers to handle the softwares. It is not so easy actually without something called as without the help of computer you can handle the software. So, that means we need computers for installing softwares to work out the particular engineering problems as per the as per the use of econometrics, and then finally you go for the kind of interpretation. And then in the case of econometric output, we have estimations, that is called as measurement, and then inference and hypothesis testings, and the last part of this particular process is called as prediction and forecasting, and then we will go for the kind of evaluation. So, that means it is a very lengthy process altogether, and it is not so easy actually. Identifying the inputs in the econometric process is somehow very simple, but getting the econometric output is not so simple, because in between there are lots of tests, there are lots of checks, or it is a kind of ultimately continuous process. Okay. So, you have to continuously testing, estimating, then finally you have to fix a particular output level which is good for your engineering problems requirement. So, that means technically it is not a one way process altogether. Yes, it looks like step by process, but it is look like one way process, but it is not like that. Yes, we have to follow the particular steps which we can which we will mention in the later stage. So, but ultimately you have to start with step by process, and at a particular point of time, if you will not get the output, desired output as per your requirement, or something going wrong, then again you revisit the particular process, again you start with particular step, and again you come to that point. So, again you have to check all these details, then if you satisfy, and this is good for your analysis, then you have to stop there. Otherwise, it will be continuously iterative process, you can say that iterative process till you get the best output as per the particular engineering econometrics requirement, right. So, now in the next process, so what we can do, so this is how okay. So, what I have mentioned earlier, that one of the biggest requirement in the process of engineering econometrics is to understand the variables. So, what I have mentioned, actually variables can be two types, a dependent variable and independent variable, and again dependent variable can be a qualitative and can be quantitative, that is numeric, and independent variables can be again quantitative and qualitative, which we have already highlighted in our previous lecture, but still I am once again I am highlighting this, because it is very important for any kind of regression modeling. Wherever you apply any kind of engineering problem, this clarity you must have, otherwise it is very difficult to go for the kind of processing, because if your classification of dependent variable and classification independent variable is wrong, then you will not get best estimated output, and you may not get the desired output as per your particular requirement. There is a kind of theorem called as a blue best linear unbiased estimator. So, we will discuss later in details about this particular theorem, but the theorem will give you the simple message that the estimated model is free from all kinds of error, and it is the best for any for analyzing that particular engineering problem. So, that means technically the theorem cannot give the optimum result until unless everything will be in a systematic reporting, or this systematic way you have to design. So, one of the requirement of this particular process is variables understanding. So, let us see how many are dependent variable, how many are independent variable, and how many are qualitative in nature, how many are quantitative in nature. So, we need actually a details kind of reporting. So, then you have to see how these variables are related to each other. Is it a bivariate case, is it a multiple case, or it is a kind of multivariate case. So, in the case of multivariate, it is a very complex kind of things, because every step you will find different kind of functional form or different kind of equation, even if your objective is very specific. Still there is a need of connection to reach that particular objective. So, that is how your clear cut understanding must be a very essential. So, now in the case of dependent variable and independent variable, which I have highlighted here. So, this is what the dependent variable and this is what the independent variable. This can be quantitative, this can be qualitative, and this can be also quantitative, and this can be qualitative. And this understanding or this reporting is very important, because on the basis of this the involvement of quantitative variables or qualitative variables, your choice of the model will be also different. So, that means there are certain econometric tools are there. It is a variable specific. If you are using qualitative variables dependent in the dependent variable case, then your model structure will be different. If it is in the case of independent variable, then the model structure will be also different. So, that is why you must see how many variables are there in the system, and how many are qualitative in nature, and how many are quantitative in nature. And we are dealing with various engineering problems, starting with aerospace engineering, biotechnology to mining engineering, and you will find different terms are frequently used. There is excellent journal called as Technometrics. So, you will find different kind of engineering problems are there and discussed empirically, and you will find the same dependent variable can be used differently by using the name of endogenous variables, explained variables, effect, control, outcome, regression, predictant, response. So, these are all called as dependent variables, and it is frequently used in different kind of engineering, but ultimately this is the basket of dependent variable. If you are using dependent variable, it is fine. Otherwise, instead of dependent variable, you can say that it is a endogenous variables, or you can say that it is a effect, you can say that it is a kind of control. And on the contrary, so the independent variables can be reported like it can be called as exogenous variable, it can be also called as a explanatory variable. Cause means if you say that independent variable is cause, then the counterpart will be called as effect, that is the dependent variable. So, when you will call as independent variable, otherwise called as control, then the counterpart is called as a control. So, that means it is altogether have a different kind of naming procedure. So, you must have actually the particular structure to understand the a kind of concept, and the detailed classification and similarity are there. There is a book called as Basic Econometrics by D. N. Gujarati. If you go through that book, in the first chapter itself, you will find this particular declarations, the difference or the similarity between dependent variable and independent variable. So, accordingly, so what is the requirement that you must be very clear about the dependent variable or independent variable. For instance, instead of independent, if I use covariate, if you are not means you are not acquainted, then you may assume that the covariate term may be the dependent variable. So, then the entire problem will be different step altogether. So, you must be very clear about these particular pictures, right. So, ultimately, so we have to move again further to know about the data structures. What I have already mentioned, there are couple of ways you can actually put the data understanding. So, it is question of big data versus small data. So, that means in the basket, if you have actually big pool of data, that is called as big data, and if it is a small data structure of the data, it is called as small data. In fact, we have a concept called as large sample and small sample. So, the large sample concept means econometrically is it depends upon sample size, let us say 32. So, if it is crossing above 32, then it is called as large samples, otherwise it is called as small small samples. So, that means large sample and small sample depends upon the number of sample points. Usually the bar is actually 30, 32, and then if it is less, then it is called as small samples, otherwise it is called as large sample. So, in other words, if you say big data, it means huge pool of data, and then if you say that small data, that not necessarily mean that in a small samples, but it is a large sample, but it is the, for instance, 50 or 100 in comparison with 5,000 or 10,000. If you say 10,000 is a big data, then 100 may be a small data. This is the kind of example or understanding you must have. Then the data can be again can be a primary kind of structure and secondary kind of structure, and we call as primary data and secondary data. Similarly, it can be a quantitative and qualitative structure, then quantitative data and qualitative data, which I have already highlighted. So, that means this is actually we have already highlighted, and quantitative qualitative I have already also mentioned, and experimental and non-experimental data, and some data are used in the particular investigation process, that is called as experimental data, and where the accuracy is much higher. In non-experimental data, the accuracy not so high, and you have to do lots of hard working to get the best output in the process of empirical testing. And then structured and unstructured data. So, that means once you have a data first hand data, that may not be in a structured form. So, because your requirement may be something different, and usually first hand data we call as unstructured, and then we put in a kind of structured format depending upon your kind of requirement. Sometimes you can do data transformation, do data transpose, something like that, and then put in a kind of structured way, so that your analysis can be much better, and your empirical investigation process will be very effective, and within a quick time you can get the empirical output. Then internal data and external data. In fact, externally we will get lots of data, and again the same data can be collected internally, and as a result you can call as internal data and external data. Similarly, data can be traditional and new data. Traditional data means it is already available, and new data means newly generated data, may be experimental process, may be non-experimental process, and free data and purchased data. That is what I have already highlighted in the context of database. Some database are freely available, and some database are data will be available with kind of purchase only. And then there is a concept called as historical data. We have a data structure called as time series data. Generally, historical data is nothing but called as time series data. So, this is altogether called as a data architecture through which you can analyze the particular process, or must have a clear cut understanding about the data used in a kind of engineering econometrics requirement. Okay. Again, in the in engineering econometrics, so far as the data is concerned, we use the term called as a metrics, and that are used to quantify some kind of variables. Sometimes measures are numerical values for values of metrics, and it may be a discrete, it may be a continuous. Discrete means it is kind of on time or not on time. This technically it can be a discrete and it can be a continuous, but continuous it is a very good for the kind of empirical testing, that is like delivery time, package weight, purchase price. So, you must be very careful whether the available data is in a discrete format and the continuous format. Ultimately, we need to analyze the particular problem if data will be available corresponding to a particular variables. If data will not available, it is very difficult to analyze the process or doing the kind of empirical investigation. In fact, some informations or some reporting in the first hand is completely qualitative, like let us say gender impact on income. So, in that case gender cannot be by default called as in a numeric format. That is how structured and unstructured concept will be coming into the picture. So, if gender is a kind of variables, then the reporting will be either male and female. If you write male and female in the data in investigation process or data analysis process work out. So, what will you do? So, you transport to male and female transfer male and female to some coding, let us say 1 2 or 0 1, then you analyze. It is very easy for doing the kind of job. So, that is how we need to know the kind of measures, and that to the matrix measures to reporting the data numerically as per the particular requirement, and the making the process easy to get the empirical output as per the engineering requirement. And by the way, so we are in the data investigation process, and the type of data structure will be like this, and I will let you know in the later stage, but what I will like to tell you that when we go for empirical investigation process, so data is the one of the vital component, and the we can call as wheel in the process of engineering. And so when we use the data for any kind of investigation process, so the reporting of data can be time series, that is reported with respect to time for a particular organization or for a particular sector or something like that. So, the time may be annually, like here we have already reported. So, it may be monthly, it can be quarterly, even if sometimes it may be also day wise reporting. For instance, monthly, quarterly, annually, weekly, these are all time series reporting. And cross sectional data means same one particular point of times, and the data is reported for a particular organization, for a particular sector, particular unit or particular individual. So, then it is called as cross sectional reporting. So, now when we are pulling time and cross, then that becomes called as pool data, and then when you are targeting the impact of cross sectional impact and time series impact on the pool data, then it becomes called as panel data. So, we have a panel data modeling. During that times I will highlight in details about the panel data structure. Start with a simple cross sectional, time series, pool, and panel. This is how the hierarchy you have to maintain to understand the data and use the data for the particular empirical investigation process. That means, in the same problems, if you have a data with time series and cross sectional, then you can go for cross sectional modeling, you can go for time series modeling, you can go for panel data modeling. So, in the later stage, we pick up a particular engineering problem, and we can use a data set where we have a cross sectional data and time series data together. Then by default we can have a many different models depending upon the use of data for the particular investigation process. The cross sectional data, cross sectional modeling, time series data, time series modeling, then panel data modeling. So, likewise it is a very interesting process. Once you understand the kind of data structure, then you can just connect with a particular model, and you will find plenty of beautiful results to analyze the particular engineering problems. So, this is all about the data structure, and then we have the kind of concept called as data analysis, means data analytics process. So, ultimately when we are dealing with data in the kind of engineering econometrics. So, one of the big component is the data collections, that is data gathering, then the checking the missing data. Sometimes when you are reporting a data for a particular variable with respect to time for a particular organization, some point of time the data is missing, or particular point of time with different organizations, some organization may be missing. That is called as sign of missing data. But ultimately when we are doing regression analysis or regression modeling or some kind of econometric modeling, so in that context you must have a data, and that means uniform data you must have for all variables. If any kind of missing, either you can drop that particular data point or you can delete that data point before you start the analysis. But deleting the data, omitting the data is not the solution. Sometimes if it is a time series data, if you just omit the data, then it may affect the time series features. So, you must have some kind of mechanism how you have to address this particular situation. we will discuss in details in the later stage. So, there is a technique called as interpolation and extrapolation, through which you can somehow manage the missing data to handle the situation, but sometimes when you use interpolation and extrapolation to use the data, some other errors may be coming into the picture, but still we can manage how to handle the particular scenario. Then we have a data visualization, and data visualization means a regression basically represents the functional relationship between variables. We will discuss details in the later stage. So, since it is a functional relationship, so we initially may not have any idea whether it is a linear kind of structure or not linear kind of structure. In that case, data visualization is a mandatory. So, once you visualize, then you can pick up appropriate functional form. If you pick up appropriate functional form, then your model will be very good and your estimation process will be very equally very good. So, you must be do the data visualization before you go for any kind of modeling. And then data integration, sometimes you have to club the data properly as per the particular requirement. And data transformation, sometimes you have a data which have lots of variety for a variable x, and you have actually 10 data points, one data point 3 digit, one data point is a single digit, one data point is double digit, like this, then you will find lots of volatile is there. So, when you have a large number of volatile, then model accuracy will be down in the process of empirical testing. So, in order to avoid such kind of problems, we can go for data transformation. So, there are many different ways you can go for data transformation, like log transformation, fast different transformations, and some kind of normalization. So, we will discuss in details about the data transformation in the later stage, and mostly we will do in the case of time series modeling. And then finally, the concept called as data analysis, and it is one of the biggest component in the engineering econometrics. If you what kind of model you have to choose, and how to go for estimation, and what kind of analysis you will do, what kind of output will you obtain, and whether you can again continuously re-estimate if your output is not coming as per your expectation. So, the process of data analysis is a very very complex and very complicated, and for that you must have a patience, and you must know all these obstacles and kind of issues and kind of problems. Then you can address the issues and problems very effectively as per your problem requirement. And finally, the kind of called as data analysis softwares. So, we have actually plenty of softwares which you can use for this data analysis, which I have already highlighted, and these are all the listed softwares which you can actually use in the kind of engineering econometrics process, starting with your SPSS, SAS, eViews, GAUSS, SPLOS, Micropit, Retail, Shazam, Minita, TSP, R, MATLAB. So, just we listed few. There are plenty of econometric softwares. It is a kind of big business now. So, but most of the softwares are more or less same. Either you connect with the programming, or you simply go by window version, just operate in a kind of mode, you will get the kind of output. So, you should know the tricks, everything before you go to the software. So, my suggestion is that before you enter to the softwares to handle the to get the output, or to make the process. So, you must be clear about the theory, clear about the models, must have a data, must have clear understanding of the variables or the functionality. Then you go to this go through the software process, and then you can easily get the output. Once everything is clear, then definitely you will get the clear cut results, and then you can equally actually analyze the problem more effectively. So, that means technically it is a very complicated process, but you can simplify if your understanding is clear and some of the infrastructural support is with you to deal with this kind of problem. So, with this we will stop here. Thank you very much. Have a nice day.